All right, good morning, everyone. How are we all doing today?
Fantastic.
All right, good, good. Does anybody recognize this image in this map? Anybody?
Pangea.
Pangea? What's Pangea?
It's a big land.
A big land? So, are these, is this what continents look like now?
No.
No? So what do you guys think is going on here? Why are they connected right here?
Mixed up picture.
Let's say that again, Paige? It is, they do fit together like a puzzle. So today we're going to be going over plate tectonics, and as Pangea was said by Peter, it was a megacontinent. And most Americans still don't believe in this, or some don't believe that plates are actually moving. And we're going to cover that and see what you guys think after this lesson. The objectives for today are up here on the board. Students will be able to define what Pangea was. Students will be able to describe the evidence for continental drift. And students will be able to explain what causes plates and everything above them to move. So this is a piece of Alfred Wegener, and he's the one that first kind of put this Pangea idea together. And this comes out of a book that he wrote in 1915. And he first started coming up with these ideas in the early 1900s. But just real quick, can I have someone volunteer just to read the first sentence of this?
I will.
Thanks, Melissa.
Scientists still do not appear to understand sufficiently that all earth sciences must contribute evidence towards unveiling the state of our planet in earlier times, and that the truth of the matter can only be reached by combining all this evidence.
What does this mean to you guys? I know it's a lot to read, a lot to handle, and it's written a little bit of an old school language, but what do you guys take out of that sentence?
That all sciences can relate to each other.
Right, and things are kind of intertwined, right? Okay. Can I have someone else read the next sentence, please? Sonny?
It is only by combining the information furnished by all the earth sciences that we can hope to determine truth here. That is to say, to find a picture that sets out all the known facts in the best arrangement and that therefore has the highest degree of probability.
Thank you. Does anybody have an idea of what that would mean to them?
You can't just base what you know on one of the earth sciences. You can't say geology has all of the answers or that something else has all the answers. You have to take the information from all of them.
Right. Take facts and bits and pieces from all the earth sciences. And then the last part, someone volunteer for that, please? All right.
Further, we have to be prepared always for the possibility that each new discovery, no matter what science furnishes it, may modify the conclusions we draw.
And what does that mean to you guys? What do you take from that?
Science is always changing.
Right.
Your
Right.
ideas.
Okay. Very good. So just remember, this was written in 1915. I mean, this is way ahead of time. So again, it was written in the early 20th century that this idea came apart. And Alfred Wegener was highly ridiculed for this. Nobody believed him. Everybody thought he was crazy for thinking that continents moved and things, you know. So his proof of this, though, was by taking the continents. You could tell by looking at them that they formed together like a jigsaw puzzle. And that the outlines of underwater edges of continents fit together even better than above water outlines. And there was other notions by people that were looking at the map that said that they could see that the continents could fit together. But this point right here, the underwater edges of the continents actually fit together even better than the outlined parts, the parts on land, was like his first real proof that this was actually going on. Before, people had no hypothesis for why it fit together. But why do you guys think that the underwater edges fit together better than the above water?
Sea level changes.
Right? But what about think underwater is always underwater, so what's not going to happen when something's underwater if it's not exposed up above the water? Right? Erosion and weather. Very good. And then one of the most profound ideas that he had and was able to prove is fossil species that were found on edges of the continents also matched with the leading edges of the other continents, the same fossil species. So that right there was able, to show that at one time they had to be connected. And we'll see another map here coming up of some different species and why there's no way they could have migrated from land to land. And then Pangea just means all lands, or the megacontinent, supercontinent that we talked about. So here's the map of some certain fossils that were found throughout Pangea and after it split. And the main one here is the Mesosaurus. It's like a crocodile, but it was only 3 feet long. So there is no way that it could have swam across the Atlantic Ocean and inhabited another continent. There's no way. So you can see, besides just animals, there's plants too. So there were some misconceptions, and Werner was wrong in one sense, that he conceived that the continents were moving through the Earth's crust like a icebreaker, like an icebreaker out in the ocean that just breaks ice and plows through the sheets. And that's what he was saying was going on through the crust, which, that's kind of far out there, but that was his only explanation for it at the time. And then he also thought that centrifugal and tidal forces are what move the continents. Does anyone understand or know what centrifugal and tidal forces are?
Centrifugal is the rotation of the earth, so,
Right?
and the tidal forces are how the moon and earth react in the cold
Right.
gravity.
And think about like the centrifugal forces and the tidal forces to cause continents to move would be, an enormous force that it'd probably start or stop the rotation of Earth and things like that is what other scientists, would say when this was his first hypothesis of it. So here's just a review of Earth's layers that you guys covered in the last unit. We have the core, which is hot, very hot, and the mantle, and then the crust. And think of the mantle is liquid, somewhat. It's magma. It's able to move. It's viscous. So on top of the crust, think of the plates are on top of there, and they're able to move because of the heat and the pressure that's given through the core of the Earth. And you can think of this as like ice floating on water. So it's a solid on a liquid, but it's still on top. Then next, every plate has a name for it. And you guys can see all throughout the world here, there's the different plates. But you can see on North America, we just have one plate. Does anybody have an idea why there's just one plate on North America? Would be just a guess, just by looking at everything else and how everything else is connected.
Like the central piece, I don't know.
Right.
So it's
Probably,
broke off.
that's what scientists do believe is because it was kind of in the middle there. So that's what we can draw from that. And then plate tectonics, just in general. So you have your plates, and then you have your oceanic basins and ridges. Does anybody know what an oceanic basin or ridge is?
Underwater mountains?
What's that?
Underwater mountains?
Right, it's just geological features that are underwater. So you can have, mountains, ridges, trenches, all that, but that also moves along with the plates. It's all moving. The plate controls the movement of everything on top of it. So, does anybody know what the asthenosphere is?
It's under the, it's under land.
Right,
Like what we consider land anyways.
right. And that's what part is that the crust floats on. It's the viscous layer. And again, think of ice floating on water, something solid that's on a liquid. And again, caused by heat and pressure from deep within the Earth. And convection. Do you guys remember what convection is from chemistry or anything? also dealing in meteorology.
The cycling of hot and cold, hot stuff rises and cold stuff drops. So
Right. Right. And here's just another analogy of that. Think of boiling water, that you're having a heat exchange and then the boiling of the water, shows convection. So here's just a diagram of what's going on inside the Earth. You have your mantle, and you have your asthenosphere, and it's the convection that's causing these plates to move. And they can be pulling apart, they can be pushing together. There's all different kinds of plates. So, for an activity, what we're going to do is I want you guys to take this envelope, and in this envelope there are pieces of each continent, and they're broken up, and then there's fossils, pictures of fossils on each side, and I would want you guys to put this together as best as you could, thinking how you would go form it together. And then for review, can anyone tell me what Pangea was?
Supercontinent.
Right. And then what is the evidence for continental drift?
Fossils.
Right?
Fossils in place.
Right. What's another one?
The way the continents fit together, or look like they would fit together.
Right, like a jigsaw puzzle. Okay. And then, can anybody explain what causes plates and everything above them to move? The actual force that's driving it?
Convection.
Right. Okay, and for my assessment, my students will be formally assessed on the activity through group work and discussion with each other and comparing how they recreated Pangea themselves, just on how it fit together. And then they'd also be formally assessed on the review questions through oral means. And one of the reasons I did this, just a side note, is when I was talking with my mentor or teacher, he told me that he didn't really believe in plate tectonics and stuff, and I found that to be really odd, so I want to be able to talk to him about it. I may not necessarily address it in my classroom if he doesn't want me to, but I definitely want to have a conversation and understand why he doesn't.